So I'm going to make a quick video explaining the questions on the practice quiz to this probability and stats quiz that we're going to be having. Taking a look at number 1, it says find the mean. So yes, you could with the calculator add them all up and then divide by 1, 2, 3, 4, 5, 6, 7, 8. Or what I would do is use Desmos. Type in this entire list into Desmos like so. And of course you use the functions button. You click the functions button and then click mean because they're asking for mean. And that'll open up the parentheses and you just type in your numbers separated with the comma, each one, 92, comma 98, comma 125, and it'll give you this answer. Now on the instructions, it says round to the nearest hundredths. So we all should know that this is the tenths place. Tenths, hundredths, and thousandths. So they want us to go up to here only, right? They don't want the thousandths. But you have to use the thousandths to determine if the 7 actually rounds up to an 8 or if it stays a 7. So if this was a 4, 3, 2, 1, or 0, it's going to stay a 7. But if it's a 5, 6, 7, 8, or 9, it's going to change this one to an 8, right? So right here, the 5 changes that to an 8. So the answer that you should type in is 107.88. That's the answer that we want when we ask to round to the nearest hundredths. Again, over here on the whole number part, like, this is ones, tens, hundreds, right? 107. But on the decimal part of it, on the right side, it's tenths, hundredths, thousandths. So if they say round to the nearest hundredths, you got to use this one to determine whether it stays a 7 or changes. In this case, the 5 changes a 7 to an 8. That's why this is your final answer. Number 2. So if you use Desmos, it's good because you have the list still there. Just double check it's the same list. 92, 98, 125. I'm looking at this thing. Wait a minute. The only thing that changed was a 97 instead of 130, right? So if you're on Desmos, you could just change the 130 to a 97, and then you'll be ready to find the median. All you have to do is go back and delete the word mean and replace it with median. So I just did that, and of course you replace the word mean with median with your functions button down here. Click functions, click median after deleting the word mean, and it'll say median, and it'll give you the median, which as you could see is 99.5. Okay, that means if we were to do it by hand and put these in order, you're not going to have a middle number. You're going to have two numbers that you have to add together and divide by 2, and that would be 99.5 if they were in order, but these aren't even in order. So you could do it by hand, but of course Desmos is way easier. So that's number 2. Let's move on to number 3. So on this question, number 3, we have the word mode, and that means the number that occurs the most. Again, mode is the number that occurs the most. So I'm going to take a highlighter and I'm just going to start highlighting whatever repeats. So I see 1 3 right here. Another 3, that's 2 3s. What else repeats? Well, there's also 2s. There's 1 2 right there, another 2, and another 2. Wow, there's 4 2s. That looks like the winner, because even 8s, it only repeats twice. I'm sorry, there's another 8 right there. But either way, the number that repeats the most is the number 2. So that's your answer. So on this question number 4, it says, what % chance is there of rolling a die and it landing on a number less than 5? So let's think about that. Rolling a die and it landing on a number less than 5. So how many sides are there on a die? Total of 6, right? And how many sides are actually less than 5? 4, right? So we want, so let me do this. The probability less than 5. Probability less than 5. There's 4 numbers that are less than 5 out of the total 6 numbers of a dice, or of a die. Okay. So it says, please round your answer to the nearest whole percent. So they don't want decimals, they want it as a whole percent. So even if you add something like 34.5, make that a 35%. And it says use the percent symbol. So all you have to do is divide 4 divided by 6 with the calculator. So that would be 0.66, and it continues, right? So you want it as a percent, so that would move it 2 decimal places over. So I guess I would need another 6 right there. So you're going to move this decimal place 2 over. So that'd be a 66.6%, but it wants the whole percent, right? Whole percent. You don't want decimals. So that means that this 6 is going to change that to a 7. So you're actually going to type in a 67%. 67% chance that it lands on a number that's either 1, 2, 3, or 4, a number less than 5. Let's try the next question. Okay, so on this particular question right here that has the king of spades, it's asking the probability of randomly selecting the king of spades from a standard 52 card deck. Okay, so we want the king of spades, and we should know that there's only one king of spades. There's only one of those king of spades. So we want that one card out of the total 52. So all you have to do is, with the calculator, divide 1 by 52. So when you divide 1 by 52, you get 0.01923, and they want it as a percent. So what do you do with the decimal? You move it over 2 spaces, so it'd be right there. That would technically be a 1.923. Now, they do want it as a whole percent without decimals. Be careful with what you read, or be careful reading the instructions. So we do want to change this to a regular 2. Right, 1.9%, it's going to make that a regular 2%. So that's why the answer should be 2%. You just type in 2, put the percent sign, no space between the 2 or the percent sign, and that should be correct. Any questions? No? All right. Let's move on to question number 6. If you roll a die, what's the probability it will land on a number greater than 4? Well, how many numbers are greater than 4? There's 2 numbers greater than 4. There's a 5 and the 6. So there's 2 that we want out of the total possible 6, right? So you could type in 2 6. I do say write it as a reduced fraction. So you reduce it by 2. That'll become a 1/3. So there's your correct answer, 1/3. And you would type it in with the keyboard 1/3. 1 divided by 3, right? So this is what you're going to type in. That'll be the right answer. Now notice I did type it in as 1/3, but it'll also give you an alternative option. If you do type in 2 6, it'll be correct anyway. All right, let's move on to number 7. This one's a little more interesting. It says, they give you this diagram, and it says if you were to select one shape at random from the array, what is the probability it'll be a heart? So we got to first understand how many hearts there are. There are, let me just highlight them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so there's 10 hearts. So we want 10 of those, right? Any of those 10 hearts, we want them over how many possible? 25. And instead of counting 1, 2, 3, 4, you could just do this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 5 is a total of 25. So there is a total of 25 right there. So this is your answer for the probability of selecting a heart. However, it says type in your answer as a percent. So how do I change this fraction to a percent? Well, you first divide. 10 divided by 25 is 0.4. And then you could change that to a percent by moving the decimal over to the right 2 spaces. So it'd be right there, but you have to add a 0. So that would make it 40%. So that's what you need to type in to get full credit on this particular question, 40%. Let's try another, number 8. What is the probability? You already see the answer there. But what's the probability of rolling a number less than 3 and flipping a coin and it landing heads? All right, well, let's first think about the probability. Let me actually write it with notation. The probability of rolling a die and getting the number less than 3. That's just notation, so I know what I'm doing here. And how many actual numbers on a die are less than 3? There's only 2 of them, right? We have the numbers 1 and 2 are less than 3. 3 is not less than 3. So there's only 2 numbers that are less than 3 out of the total 6 numbers that are on the die. Okay? So this is the probability. This is the probability of rolling a number less than 3 on a die. This is it right here. You could reduce it to 1/3, or you could just leave it like that for now. Now, it also says you want this to happen and flipping a coin and it landing on heads. Flipping a coin, flipping a coin and it landing heads. So let me actually do the notation for that. I'm going to put the probability of heads. Okay, so obviously that would be one side that has heads out of the two sides of a coin. So we need to multiply these together because this is a compound probability. So 2 times 1 is 2, 6 times 2 is 12, and of course that reduces down to 1/6. So your answer should be 1/6, and that's what you're going to pick right there, 1/6. Alrighty, let's move on. Question number 9. On this one, this is probably one of the more challenging questions. I would write down everything that you think is important. Like, for example, there are 2 black marbles. 2 black. Okay, 3 red. 3 red. There's 4 blue marbles. 4 blue. Why did I change the color? I don't know. Anyway, there's 11 yellow marbles. 11 yellow. Okay. Maybe I should have done this one to 2 black. There you go. Anyway, so how many total marbles do we have? 20. It's 20 marbles. Okay, now we need that total on the denominator of any probability. Okay, so let's continue reading. This is just something that we need to know, but let's continue reading. It says, you reach in the bag, select the marble, see what color it is, and then replace it in the bag. And then you do this process again a second time. What is the probability of picking a blue marble both times? Okay, so let's first begin with the probability of blue, and this is with replacement. So what is the probability of blue 2 times? Well, what's the probability of blue 1 time? How many blue are there? 4 out of 20. Okay, and then if you pick that blue one out and then you put it back in and then shake the bag up again and then pick it again, what's the probability of getting the blue the second time? 4 over 20 again, right? But the probability of both of those blues happening back to back, that's where you have a compound inequality. It'd be 16 over 400. And 16 divided by 400. So when you divide 16 divided by 400, you get 0.04. And as a percent, you would move it 2 spaces over. That'll be a 4% chance. 4% chance. So that's what you type in. Or actually, it's multiple choice, 4%. Let's move on to number 10. So on this is one of the more challenging questions, number 10 right here. I don't know if you could read it from there, but it says, suppose you have a bag containing 4 black marbles, 3 red marbles, 2 blue marbles, 11 yellow marbles. Let's first start by writing down what's important. So 4 black marbles, and then we have 3 red marbles, and then we have 2 blue marbles. And last but not least, we have 11 yellow marbles. Okay? That's a typo. It says marble, but 11 yellow marbles should be with the S. My bad. Anyway, why am I writing all this down? Because on any probability, you need to know the total. Okay, so what's the total? How many marbles do we have? 20. Right? Total is 20. Okay? So now that we have that important information down, now we could actually read through and see what they're asking. Okay, so it says, you reach in the bag, select the marble, see what color it is, and then it says, do not replace it. These are the key words right here. Do not replace it. Okay? And then you reach in again for a second marble. What is the probability of picking a black marble both times? So you want the probability of black times the probability of black, right? You want it 2 times. So let's start with the first one. What is the probability of black? How many are black that we want? 4 out of the 20. That's right. Now, because it says do not replace it, let's assume that you did pull out a black marble. Okay? And now you want another black marble, but you never put it back in. It's outside. So how many black marbles are left? 3. And it's no longer a total of 20. Now it's what? 19. Okay? So yeah, the first time you had 4 in there out of 20. But if you pull it out and don't put it back in, if you take that blue marble out, now there's only going to be 3 blue marbles left, and there's only going to be 19 total. So we need to calculate the multiplication of this right here, which is 12 over 380. Okay. Now, how do they give us this? They give it to us in percents. Okay, so let's actually divide with the calculator 12 divided by 380. Okay, so the answer, 12 divided by 380 is 0.031578895. Okay, now we want it as a percent. And how do we change a decimal to a percent? You simply move it 2 spaces to the right. 1, 2. So what's your answer going to be? 3.157895. But if you want the whole percent, it's just 3%, because the 1 does not change the 3 to a 4. It's just about 3%. So on the multiple choice, you will select 3%. That'll be the correct answer. Okay. So that was a good point brought up right now, that you could have reduced 4 over 20 to 1/5, right? That would have been easier to deal with. So you'd have 1 times 3, you get 3, and you'd have 5 times 19, it'll be a smaller number. And then you'd still divide, but it would still give you the same answer. Okay, so it's up to you if you guys want to reduce, or if you just want to work it through with the calculator. You should get the same answer either way. All right, let's move on to another question. So on this particular question, we're selecting the true statements. First one, picking 2 yellow marbles in a row without replacement would be considered a dependent event. What do you guys say, true or false? True. That's definitely true. Okay, without replacement. So if you pull out a yellow marble, there's going to be less yellow marbles in there the second time you do it. So that second event depends on that first one, right? It actually changes it. If you replace it, then it's independent. Without replacement, it's dependent. Okay, how about this next one? The probability of some event occurring is taking the total possible outcomes and dividing it by what you want. No. It's the other way around, right? It's what you want divided by total possible. So this next one is false, right? That's not true. Rolling a die and flipping a coin are dependent events. No, that's false. They're totally independent, right? Rolling a die doesn't affect how you flip a coin, or flipping a coin doesn't affect how you roll a die. What about this next one? To change a fraction to a percent, you simply divide the numerator by the denominator, get a decimal answer, then move the decimal 2 spaces to the left. Yes. False. It's 2 spaces to the right. So that left right there makes this false. Does that make sense? And keep in mind, on the actual test, I go through all of these and I change a word or 2. So make sure you understand the concept, not just which ones are true and which ones are false. These are fun. Number 12, it says, what is the probability of flipping a coin 4 times and all 4 times they land on heads? So let's not worry about 4 times. How about just 1 time? All right. What is the probability of it landing on heads 1 time? The probability of heads. That's 1 out of 2, right? Now, compound probabilities, when you want things to happen together, like if you want it to happen 4 times in a row, then you got to do the probability of heads times the probability of heads times the probability of heads times the probability of heads, right? So that's really going to be 1/2 times 1/2 times 1/2 times 1/2. So what's your answer going to be? 1/16. Okay? And I do want you to type it in as a fraction. So on your keyboard, obviously there's no fraction button. So you're just going to type in 1/16. That's how you got it. But I also went through and made the alternative. You could, if you left it as a decimal, I'd still give you credit. If you put it as a percentage with the decimal, I'll still give you credit. Or if you rounded it up or rounded it to the whole percent, regular 6, that would also be true. Let's move on to the last one. Same type of question, number 13. What is the probability of rolling a die 4 times and it landing on a number less than 3 all 4 times? Okay, well, let's first find the probability of rolling a die and it landing less than 3. How many numbers are less than 3? Okay, so there's 2 of them that we want over how many possible? 6. All right. Now, we want it to land on the numbers 1 or 2 4 times in a row. So I need to take this probability, which is technically 1/3, it's probably better to reduce it to 1/3, and multiply it with itself 4 times. Does that make sense? So we know 1 times 1 times 1 times 1 ends up being 1. 3 times 3 is 9, times 3 is 27, times 3 is 81. So there's your answer, 1 over 81. Type it in 1/81. Or if you actually divided it and made it into a decimal to get this crazy decimal, that's also acceptable, even though I asked you for a fraction. If you rounded it to the nearest thousandths, that'd be 0.012. Or if you wrote it as a percent, it'd be 1.2%. Or you could have even typed it in as 1%. Anyway, if I ask you for a fraction, go ahead and type it in as a fraction. That's the safest thing to do. Any questions? No?